Hi, welcome to clickmyproject.com. Now we are going to see the process of a machine learning approach for identifying disease treatment relations in source text. Actually, this the core of the process is there is the application of natural language processing and the machine learning techniques, in which they have represent the extraction of the useful information by means of some classification algorithms and to extract the relevant medical information in by source text. And the main abstract of the process is the input we take in the form of from the Medline database. Actually, Medline database is a form of some rich source of information in order to identify the biomedical information, and it contains some bibliographic information. Our main application or main proposed process is to identify or extract the semantic relations between the disease and the treatments, the medical entities, and some of the medical entities. Actually, it leads to the innovation of the today's recent ontologies, and also moreover we used some machine learning approach for the semantic relations between the disease and treatment. And moreover we found the relational identification between the cure, prevention, side effects from the disease and treatment relations, and it is found out by means of some of the mathematical applications such as precision recall and F measure in order to reveal the relational identification between the disease and treatment. Next we are going to see the flow of a process. The input we take in the form of the medical information called the Medline database. The input database is also in the form of the HTML format. This is a web file. So we have to, in order to extract the informations, we have to convert it into a text format or data format. Then we have to extract some sentence. We have to extract the information in the form of sentences. So for that we select two attributes. There is the disease, and our code is to separate or make the data in the form of the disease and the treatments. Okay, then we have to relate the disease and treatments by using some algorithms. For example, first we have used the stemming algorithm. Using that stemming algorithm, first we extract the word from a root word. For example, I am going to extract the word from the root word stemming. Likewise, the stemming algorithm applies, it extracts the words from the root word. Then we applied the stop words algorithm. Using the stop words algorithms, we make certain parts of speech and the split the words. So the parts of speech, likewise we split it into nouns, verbs and pronouns. Likewise the words are removed, and also it is the good way of removing some redundant data from the medical databases. At last, the extracted information contains three things: that's the cure, prevent and the side effect. Therefore we are further we are going to relate some relational identification between these cure, prevention and side effects. Then we gonna see that the overview of that the entire process. Likewise we said that is a medical information. We are going to make just an extraction of the text. Therefore we make a sentence selection. Therefore we remove some redundant words from it. At last we achieve the semantic relation between the disease and treatments. Therefore we can able to find the relational identification between the cure, prevention and side effects. Next we are going to see the demo of the process. First here on the homepage.java. So in this process, in the machine learning process, we are on the first step we are taking, just click it. Just these are the 5 kinds of process which I am going to discuss in this process. First, in the process we are going to convert the HTML to text. Next, the special character removal. Then we are going to extract the semantic informations. Then we collect the data in the form of cure, prevention, side effect. At last we are going to find the relational database, relational identification between the cure, prevention, side effect, and at last analysis graphs. First, in the process we just pick up any Medline data from the any the folder we have placed. just pick it, go to that machine, inside that midline data. So here select any disease HTML file. For example, I am selecting the cancer.html. that cancer related information will be, we are going to extract the cancer related informations. Then give extract, give extract button. Then all the contents which is present in the cancer related information which will be displayed, then click remove all. Then we are going to make the extract the special characters from this information. Then we are going to the special characters, some one kind of application of stemming process. Then we are applying the stop word process. When I click the stop word process, actually here when applying the stop word process, the pause of speech process will be happen. For example, it extracts the nouns, pronouns, verbs. Likewise, the contents are arranged and it will be displayed. You can see that the most extracted information, nouns, verbs, will be extracted in the form of words. Then we are going for semantic process. Then here we are extracting some information, the semantic information. Likewise, we are characterizing the information in the form of symptoms, causes and treatments. So actually we retrieve the whole data from the raw information of the cancer data set. Then first we store the data in this format. For example, I am giving the cancer in the form of cancer name. Just store it, it will be stored. Then after that you can see the support vector here, give save file. It will be saved, the keywords are saved here, and show. When I click the show button, here we use some machine learning tool called Vega tool, and it will be called. So in this Vega tool, we called this Vega tool is used to display the attribute relationships, attribute relational information we are going to extract here. For example, I am giving actually the symptoms, cure, prevention and side effect will be stored in the form of attribute relational information, and that will be stored in the form of ARF. .arf means that attribute relational file format, it will be stored. That will be the input for this Vega tool. When I give this, here the attributes are characterized like symptoms, causes and treatments, and their processes will be displayed in the form of graphs. Then here after that we are going to find the relational identification process. So here the for applying the relational identification, first we select the type of disease we are chosen right from the beginning, then click, then it is found match means that information will be retrieved, and after that its values are extracted. Here we are going to make a relational comparisons between the two disease. The one which are we are going, this is the first one we are extracted till now. Here it will be stored in the database folder. It will be stored in the database folder found in the D drive. Here the data, the cancer data, the semantic extracted data will be, the saved data will be given here. And after that also given another data set, another semantic data set which will be found in the D drive, the database folder. For example, I am giving any semantic extracted data set lung cancer.txt. These are the formulas. This is the precision, recall and F measure. Here the precision is the number of matched words by number of total words. Here the recall means number of matched words by number of relevant words, and the F measure means the mean between the precision and recall. So these are the formula which are going to apply for predicting the relational identification between the two data sets. Then I am giving these values. It will show the values. Here it is the value between the data set which shows the relational identification between if If it is this values are larger, means it is having the more and more the equal symptoms. Likewise, we are predicting the relational identification. At last, we going to analysis by its graph. Values means here the precision recall F measure values will be shown according to that values. After that, comparisons. This is a word count before between the raw data set and the extracted data process that we are applied. After the extraction, the word count will be redundancy will be reduced. Before the extraction, there are more words or there is a more redundancy is present, that will be shown here. After that, count. Here is the symptoms, causes and treatments. So it is the values that shows the relevant data of the exact symptoms and causes treatment is shown. So all through the process we have achieved the semantic extraction of the data from the medical database, and also we achieved the relational identification between the two extracted data sets by applying the machine learning algorithms called stemming, stopwords, and some mathematical applications like precision recall and F measure. Thank you for watching.